Maple syrup is a concentrated solution of sugar and water with many minor flavoring compounds. Under the right circumstances, the maple syrup can form crystals, the crystals changing in length and shape depending on the temperature. Maple syrup was first collected and used by the indigenous people of North America. The sap can be collected by boring a hole inside either a sugar maple, black maple, or red maple tree. The scientific method has 6 steps. Ask a question, do background research, construct a hypothesis, test your hypothesis by doing an experiment, analyze your data and draw a conclusion, and report your results and conclude whether your hypothesis was correct. This is a Brix scale. A Brix scale is used in the United States to measure sugar content. Maple syrup is a stable solution at 66 Brix, but once the syrup is heated above that, the concentration of the sugar in the syrup increases as the temperature increases and the water is lost. It still remains a solution no matter how hot you boil it, but the sugar concentration becomes more and more packed as the water evaporates. If the supersaturated sugar is stirred while it is cooling, the tendency to form crystal increases. Honey is often used in candy making since it promotes supersaturation by inhibiting the formation of crystals. The objective of my experiment is how does the rate of cooling affect crystal structure? My hypothesis is, I think that the hot maple syrup put onto the sheet of ice will form crystals bigger and faster than the room temperature ones. The control of my experiment is how hot the maple syrup is boiled to. The manipulated variable is what surface the maple syrup will be put onto. The responding variables are how big the crystals grow and how fast they start to appear. To start my experiment, I first took 2 baking pans, and I froze one of them over with ice while leaving the other one at room temperature. Then I boiled about 2½ cups of maple syrup and watched what happened. The syrup turned very bubbly and I could see traces of sugar on the bottom. But when I put 1 spoonful of boiling maple syrup on the room temperature tray and one on the ice, it just turned into a flat blob. It didn't crystallize even after I waited for 15 minutes. So I redid the experiment, hoping to get different results. I boiled the maple syrup for a longer time to get the concentration of sugar to rise, but I got the same result. I was going to use this data table to analyze my data, but since I didn't have any data to analyze since my experiment didn't work, I had to find out why it didn't work. I found out that maybe it didn't crystallize because if even a couple molecules are different sizes and shapes than the others, they won't fit together and the crystals can't form or grow. This is a sugar molecule, and if any of the molecules were different than this, then it wouldn't have fit together in the way that it needed to become a perfect crystal. Another reason that maybe my experiment didn't work was maybe the consistency of the syrup. Although I was using 100% maple syrup like it required, maybe the brand I was using was too liquidy. So when I poured it onto the baking pan, the sugar molecules were too spread out from each other and they couldn't build onto each other like they needed to. The last possible reason that I could find for why my experiment didn't work is also with the maple syrup. I rechecked the label to see if any lemon juice or acids were added, because sometimes the company does that specifically so that the maple syrup won't crystallize. But I found none. The only ingredient was pure maple syrup. But it's also possible that maple syrup from any brand contains natural acids, which could keep the syrup from forming crystals. This could happen unknowingly, just from inside the tree, not during the manufacturing. So I think that's what happened to my maple syrup. But even though my experiment didn't work, I was still pretty interested in maple syrup itself. I was surprised to find out that maple syrup actually has some health benefits. For example, the trace mineral manganese is an essential cofactor in a number of enzymes, important in energy production and antioxidant defenses. 1 ounce of maple syrup supplies 22% of the daily value for this important trace mineral. Maple syrup is also a good sweetener if you are trying to protect the health of your heart. The zinc supplied by maple syrup, in addition to acting as an antioxidant, has other functions that can decrease the progression of atherosclerosis. It also helps prevent endothelial damage caused by oxidized LDL cholesterol and other oxidized fats. Since I did extra research on maple syrup, I thought that I would also do some research on crystallization, since those were the 2 key points in my experiment. Crystallization is the natural or artificial process of formation of solid crystals, precipitation from a solution, melt, or more rarely deposited directly from a gas. Crystallization is a chemical solid-liquid separation technique. I also found this cool video of a time lapse of alum crystals growing. Even though it was pretty obvious what my conclusion was, I still had a lot of fun doing this experiment and I learned a lot about crystallization and maple syrup.